Alrighty guys, let's take a look at our first problem. So we have a man opening a 1.1 meter wide door by pushing it with a force of 58 newtons perpendicular, meaning that the angle is 90 degrees to its surface. We want to figure out what the magnitude of torque that the man applies to the center of the door is. So here is our door. And let's say that R, like we said, is 1.1 meters. So the center of the door would be half that distance. I know that torque is equal to force times the R times sine of my angle. It tells me that it's perpendicular, so that's 90 degrees here, which is just 1. I'm left with torque is equal to force, which is 58 times R. We said R is 1.1 and it's at the center, so that'd be divided by 2. Go ahead and solve for this, and we find out that the torque exerted on the center of the door should be 31.9 Newton meters. Now that we know the torque at the center of the door, we want to figure out the torque at the edge of the door. So there's two ways to do this. One is to do the same steps that we did before, or two is just to multiply this answer by 2. We know that the force is 58. We know that the total width of the door is 1.1 meters, and we know that the sine of 90 degrees is just 1, so we can ignore that for now. Multiply all this together, and we get 63.8 Newton meters, which is 2 times the torque at the center of the door. Let's take a look at problem number 2 now. We have a worker applying a torque to a nut with a wrench that is 0.45 meters long. Because of the cramped space, she must exert a force upward at an angle with respect to a line from the nut through the end of the wrench. That just means that she's applying a force perpendicular. If she exerts a force of 80 newtons, what magnitude of torque will she apply to the nut in each situation? So again, we know that torque is equal to force times the distance from that center point times sine of our angle. So the first question says 60 degrees. Well, the force is 80 newtons. The distance from it is 0.45 meters, and the angle is 60 degrees. If I multiply all this stuff together, I find out that the torque she exerts at a 60 degree angle should be 31.18 Newton meters. Now I'm going to go ahead and solve for the torque exerted at a 45 degree angle. Same force, same distance away. The only thing that's changed is the angle, and now it's 45 degrees. I solve for this one. I get 25.46 Newton meters. And then lastly, I'm going to solve for the torque exerted at a 30 degree angle. Same force, same distance from the pivot point. The angle now is 30 degrees. Multiply everything through, and you get 18 Newton meters. If you are not getting these answers, odds are that your calculator is in radians, so make sure that your calculator is in degrees when they give you degrees. Let's take a look at another problem here. This says use the diagram above. We just mean this diagram over here. So assume the top right hand facing force is 15 newtons. So this guy right here is 15 newtons. Assume the outer radius is 0.4 meters. So this is 0.4 meters. How much torque is being exerted by the 9 Newton force? So our 9 Newton force is right here. We know that torque is equal to force, which is 9, times the distance from that pivot point, which would be 0.4, times sine of our angle. This is perpendicular to our axes, so therefore it's just sine of 90 degrees, which is just 1. So in this case, it's just force times the distance from that pivot point. We multiply these two together, and we end up with 3.6. If we notice, though, this is going clockwise, and we know that clockwise should be negative. So we end up with negative 3.6 Newton meters. Now if we take a look at the 12 Newton force, 12 Newton force is right here. We have torque is equal to that force, which is 12 newtons, times this distance away from the center. Well, this one's only 0.1 meters away from the center. So this would be 0.1. And we see that this is going counterclockwise. So this would be a positive torque. If we multiply everything together, we get 1.2 Newton meters. Lastly, we're going to go ahead and solve for the 15 Newton force. We have torque is equal to the force, which is 15 newtons, times the distance. Well, this one's on the outer edge, so that's 0.4 meters away. Multiply those together, and we end up with 6. But again, this is clockwise, so because it's clockwise, it's going to be negative 6 Newton meters. Our last question asks us to solve for the net torque. So the net torque is just going to have us add all those torques up. So I have 1.2 minus 6 minus 3.6. I end up with a torque of negative 8.4 Newton meters.